Today's exam question, this is a science exam question and it's very long. It needs you to understand the properties of metals and non-metals. You need to understand the three states of matter and their properties. You need to understand the atomic structure and the configuration. So I'm just going to get straight to the question. It says, using the information below to answer question 1. Use the information below to answer question 1. I get. Then it goes on to say silicon is a non-metallic element. Then it says some of the properties of silicon are similar to those of metals. We're told silicon is a non-metal. Now we're also told that some of the properties of silicon are those of what? Of metals. Then it says the following is a list of some properties of silicon, meaning silicon is shiny and gray in color. It is hard but brittle. It melts at 1410. That's a very high melting point. It forms an acidic oxide. Then it says which two properties of silicon are similar to those of metals. So I'm just going to give you a brief property in terms of the properties of metals and non-metals. So one thing you need to know about the properties of metals is that metals are lustrous. When we say lustrous, we mean they're shiny when polished. And they're malleable, meaning you can hammer them into different shapes without breaking. They are ductile, meaning you can draw them into wires. Metals are also good conductors of heat and electricity. Metals are hard and strong. Most of them, they have a high density, a high melting point, and high boiling point. They also produce a ringing sound when they're hit. So we say they are sonorous. Then non-metals, lastly, also metals will react with oxygen to form what you call basic oxides. That's it. And then now let's talk about the properties of the non-metals. Non-metals, they are dull and not shiny. They are brittle. Brittle means they easily break when you hit them. Those are poor conductors of heat and electricity. The density is low. They also have low melting point and boiling point. They are not sonorous at all. When they react with oxygen, they will form what you call an acidic oxide. Now, question 1A are which two properties of silicon are similar to those of metals? First, metals are shiny and gray in color. That's correct. Metals are hard but brittle. Metals are not brittle. What's brittle is non-metals. Metals melt at 1410 degrees Celsius. That's a very high melting point, so that's correct. Metals have a high melting point. Then forms acidic oxide is not correct because the metals had react with the oxygen, they form what you call a basic oxide, not acidic oxide. So your answer to the properties that are similar to those of metals is going to be shiny and gray in color and then melts at 1410 degrees Celsius. You need to read the question and understand what it wants. Okay. Then it says, what is the physical state of silicon at room temperature? What do we know so far? We are told that silicon in this case is a non-metallic element, but some of the properties of silicon are similar to those of metals. So what do we know? We know that most metals are solid at room temperature except what? Mercury. So which means silicon in this case is what? It's a solid. So your answer is just solid. The explanation that I wrote in bracket doesn't apply to this. So our answer is going to be the physical state is solid. We have three states of matter, which is a solid, a liquid, and a gas. Let's go to B. Second part says describe the arrangement and the movement of particles in a silicon element at room temperature. The arrangement and movement. Basically, they're looking for the arrangement and movement of particles of a solid particle. So solids, what do we know about solids? We know that the arrangement of particles, how are particles arranged in a solid? They're closely packed, or you can say they're tightly packed in a uniform arrangement. Then in terms of movement, particles in a solid, they don't move. They just vibrate about fixed positions. So you also need to know about the properties, a liquid and a gas in terms of both arrangement and movement. So if you take a liquid, for example, the particles are far from each other. In terms of movement, they flow, they move, but it's not as fast as in gases. And then the particles in a gas, in terms of arrangement, they are further apart. And they move, in terms of movement, they move freely. Then we're going to do the last part of the question. It says, in the space below, draw the atomic structure of silicon, showing all electrons, and then indicate the number of protons and that of neutrons in your drawing. It says, refer to your periodic table. So if you take a look at silicon, I've already written the mass number and the proton number for silicon, getting it from the periodic table. As you can see, we have Si, which is the symbol for silicon, and 28 ko godimo, 14 ko tlase. That 28 ko godimo means the mass number. But please, periodic tables are different. So you can have that 28 a le ko tlase, the 14 a le ko godimo. So basically, you just need to know what the mass number is the largest number. Then the proton number is the small number. So now, that 28 is what we call the mass number. That 14, we call it the proton number or atomic number. Okay? So number of protons are 14. Number of neutrons, to find the number of neutrons, you're going to say your mass number, which is 28, minus your proton number or your atomic number, which is 14. So 28 minus 14 gives you 14. So that's the number of neutrons. So your neutrons are the 14. Now, when it comes to the configuration, for you to draw your atomic structure, you need to first do under configuration. I think you can see 14, then the semicolon 2,8,4, then configuration. So what that means is that in terms of drawing our atomic structure, we use what we call the number of electrons. So in this case, the number of electrons, because this is an atom. So in an atom, there's a statement that I wrote here. In an atom, the proton number is equivalent, meaning it is equal to the number of electrons. So right to the proton number, there are 14. So which means the number of electrons are also 14. Now what we're going to do as our configuration is the number of electrons, which is 14. The first shell can get a maximum of 2 electrons. That's why we have 2, comma. The second shell gets a maximum of 8. So if you add 2 plus 8, you have 10. It means you are left with how many electrons? 4. Those 4 are going to get in the last shell. Now, in terms of drawing, the inner shell, we start from the inner shell. So the inner shell is going to have 2, followed by the second shell having 8, and then the third shell having 4 electrons. So that's what we call the atomic structure of silicon. Now, you also need to indicate how many protons and how many neutrons are there. Protons are 14, and remember that protons have a positive charge. Neutrons are also 14, and remember that neutrons have a neutral charge. So that's basically the science question. This is a very long question, but also very simple. So you need to know what you're doing.